Sign test of non-parametric statistics. Objective. Test hypothesis using the sign test. Sign test was divided into two categories: the single sample sign test and paired sample sign test. Single sample sign test. The simplest non-parametric test, the sign test, for single samples is used to test the value of a median for a specific sample. When using the sign test, the researcher hypothesizes the specific value for the median of a population. Then, he or she selects a sample of data and compares each value with the conjectured median. And if the data value is above the conjectured median, it is assigned a plus sign. If it is below the conjectured median, it is assigned a minus sign. And if it is exactly the same as the conjectured median, it is assigned a 0. Then the number of plus and minus signs are compared. If the null hypothesis is true, the number of plus signs should be approximately equal to the number of minus signs. If the null hypothesis is not true, there will be a disproportionate number of plus or minus signs. Test value for the sign test. If the sample size is 25, the test value is the smaller number of plus and minus signs. For example, if there are 8 positive signs and 3 minus signs, the test value is 3. Take note that sample size is the sum of plus and minus signs. If the test value is less than or equal to the critical value, the null hypothesis should be rejected. Note that use Table E in Appendix to determine the critical value for a specific A or alpha level. And now let's proceed to our example, or exercise 1, snow cones sales. A convenience store owner hypothesizes that the median number of snow cones she sells per day is 40. A random sample of 20 days yields the following data for the number of snow cones sold each day. She have 18, 30, 39, 36, and so on and so forth. At alpha level is equal to 0.05. Now test the owner's hypothesis. To test the owner's hypothesis, we can follow these steps. Step 1. State the hypothesis and identify the claim. Our null hypothesis is median is equal to 40, which is the owner's claim. And our alternative hypothesis is median is not equal to 40. Step 2. Find the critical value. Compare each value of the data with the median. If the value is greater than the median, replace the value with a plus sign. If it is less than the median, replace it with minus sign. And if it is equal to the median, replace it with a 0. The completed table follows. 18 was assigned negative since 18 is less than 40. Now we have another negative. It is negative since 30 is less than 40. And just follow the concepts. If the data is equal or the same as the median, just assign 0. In step 3, compute the test value. Count the number of plus and minus signs obtained in step 2. So our step 2, we have 15 minus signs and 3 plus signs. Therefore, our test value is 3. Step 4, make the decision. Compare the test value 3 with the critical value 4. Remember that critical value is obtained by the use of Table E in Appendix at specific alpha level. If the test value is less than or equal to the critical value, the null hypothesis is rejected. Again, if the test value is less than or equal to the critical value, the null hypothesis is rejected. In this case, the null hypothesis is rejected since our test value is equal to 3 and our critical value is 4. 3 is less than 4. Therefore, uh, the, the null hypothesis is rejected. Step 5. Summarize the result. There is enough evidence to reject the claim that the median number of snow cones sold per day is 40. And take note, formula for the z-test value in the sign test when sample size is more than 25. Just use this formula. Z is equal to x plus 0.5 minus n over 2 all over square root of n over 2, where x is equal to the smaller number of plus or minus signs, and n is the sample size.
Next, we will discuss about the paired sample sign test. The sign test also be used to test sample means in comparison of two dependent samples, such as a before and after test. When the condition of normality cannot be met, the non-parametric sign test can be used. Example, air infections in swimmers. A medical researcher believes the number of air infections in swimmers can be reduced if the swimmer used earplugs. A sample of 10 people was selected, and the number of infections for a 4-month period was recorded. During the first 2 months, the swimmers did not use the earplugs, and during the second 2 months, they did. At the beginning of the second 2-month period, each swimmer was examined to make sure that no infections were present. The data are shown here at A is equal to 0.05. The question is, can the researcher conclude that using earplugs reduced the number of infections? So we have a table here showing the number of ear infections. We have the swimmer from A to J and the before and after they use the earplugs. So as we can see, we have the number here of the ear infections from the before and after. So we have 5 steps here in answering our example. Step 1 is state the hypothesis and identify the claim. Step 2 is find the critical value. Step 3 is compute the test value. Step 4, make the decision. And lastly is summarize the result. So let's answer our example. So in step 1, we have here the number of ear infections will not be reduced. And our hypothesis is the number of ear infections will be reduced. So we have for the step 2, we have a table here showing the sign of difference between the before and after using the earplugs. So the sign of difference showing the positive and the negative of using earplugs before and after. For our step 3, we have to count the positive and negative signs found in step 2, which is the table, and use the smaller value as the test value. So there are 2 negative signs, so our test value is 2. In step 4, there are 2 negative signs, and the decision is not to reject our null hypothesis. So the reason is that n is equals to 9 and CV is equals to 1 and 1 is less than 2. So in step 5, that there is not enough evidence to support the claim that the use of earplugs reduced the number of ear infections.
When conducting a one-tailed sign test, the researcher must scrutinize the data to determine whether they support the null hypothesis. If the data support the null hypothesis, there is no need to conduct the test. In example number 1, the null hypothesis states that the number of ear infections will not be reduced. The data would support the null hypothesis if there were more negative signs than positive signs. The reason is that the before values x sub b in most cases would be smaller than the after values x sub a, and the x sub b minus x sub a values would be negative more often than positive. This would indicate that there is not enough evidence to reject the null hypothesis. The researcher would stop here since there is no need to continue the procedure. On the other hand, if the number of ear infections were reduced, the X sub B values for the most part would be larger than the X sub A values, and the X sub B minus X sub A values would most often be positive, as in example 1. Hence, the researcher would continue the procedure. A word of caution is in order, and a little reasoning is required. When the sample size is 26 or more, the normal approximation can be used in the same manner as in exercise 1.